This is OwlUp, where learning happens in minutes, not hours. For a deeper journey, explore all our courses at owlup.co. Now, let's dive in. Welcome to Chapter 4 of Vibe Coding, where we're pulling back the curtain on how AI actually creates the code you've been using to build your apps. We'll break down what's happening behind the scenes when you ask AI to write code, and why understanding this process will make you a much more effective non-developer developer. Let's get into it. Your next pull request might be written by something that's never run a program in its life. A system that just predicts the next token ends up shipping real features. So here's the puzzle. How can code that doesn't understand still fix bugs you've chased for days? Developers aren't just pasting in AI snippets. They're quietly redesigning how they think about code. In GitHub's 2023 study, people using Copilot finished tasks 55% faster, not because the model understands more than they do, but because it offloads the parts of programming that feel like tracing the same maze over and over. That speed comes with a twist. Stanford researchers found AI-generated code without security guidance was more vulnerable than human code. So you get acceleration and amplified risk in the same tool. Meanwhile, competitive systems like AlphaCode can already match mid-tier humans on tricky problems, and Stack Overflow's reported traffic drop hints that developers are asking machines questions they once asked each other. The real shift isn't just faster coding. It's learning when to trust, when to doubt, and how to read AI output as critically as any human PR. LLMs don't read your code like a senior engineer. They swim through statistical patterns in billions of repos and spit out what usually comes next. That makes their output feel eerily right, even when it's subtly wrong. And because the syntax is polished, our brains relax. We review it more like autocomplete than a critical code review. The result is a weird new workflow. You're half author, half editor, negotiating with a system that can refactor a file in seconds but has no stake in whether your app works tomorrow. To use that well, you need a new skill: reading AI code as if it were written by an overconfident intern with perfect typing speed. Here's where things get strange. The better AI gets at looking like good code, the more dangerous it becomes to read it lazily. Most devs already have an internal smell test for junior written code. You scan for missing edge cases, weird variable naming, suspiciously short functions that should be longer. With AI output, that intuition misfires because the surface polish is so high. Names are consistent, patterns look idiomatic, comments are plausible. It passes the aesthetic test, so you subconsciously downgrade it from untrusted to probably fine. The fix isn't to distrust everything, it's to change what you trust. Instead of asking, "Does this look like code I'd write?" ask, "What assumptions is this code quietly making? Where could this fail in production, not just in a toy example? If this is wrong, how would I even notice?" That shifts you from line-by-line proofreading to threat modeling the suggestion. For example, when an assistant generates a database query helper, your real review target isn't the select syntax, it's, does this ever run with unvalidated input? How does it behave under concurrent load? Is there a clear boundary where I can wrap tests around it? A useful tactic is to classify AI suggestions into 3 buckets before you accept them. 1. Mechanical code. Pure boilerplate, adapter layers, DTOs, type definitions. Low risk, but still worth a quick glance. 2. Business logic. Anything encoding rules, prices, permissions. High risk. Always demand tests or write them immediately. 3. Cross-cutting concerns. Auth, logging, caching, error handling. Medium to high risk, because subtle mistakes here echo everywhere. Notice how this reframes prompt engineering. You're no longer just coaxing the model to produce nicer snippets, you're steering where it's allowed to help. Let it go wild in mechanical land. Be stricter and more explicit around business logic and cross-cutting code. Specify invariants, performance constraints, failure modes. And when something feels off but you can't pinpoint why, Treat the model like a collaborator you can interrogate. Show me input-output examples for edge cases, or explain how this handles time zones. You're not asking because it truly understands. You're forcing it to surface variations that make hidden flaws easier to spot. A practical way to sharpen that overconfident intern filter is to practice on small, contained tasks where failure is cheap. Ask your assistant to write a function that parses a gnarly date format or a tiny caching wrapper around an HTTP client. Then, before you even run it, write down 3 ways it might break: odd locales, leap seconds, concurrent requests. Use those guesses to drive tests and see which ones the generated code actually fails. Think of it like a coach watching a new athlete. You don't just time their sprint, you watch how they move when they're tired, under pressure, or doing drills they weren't expecting. The goal isn't to prove the model bad or good, but to map its blind spots relative to yours. Over time, you'll notice patterns. Maybe it's consistently weak on boundary conditions, or it mishandles partial failures in distributed code. Those patterns should feed back into your prompts. Include explicit handling for X. Assume Y can fail halfway through. Show test cases for Z. Teams that lean into this shift will redesign workflows. Stand-up start including, which parts did you let the model touch? And code reviews split into human-critical versus assistant-drafted sections. Senior devs become more like editors, curating style, architecture, and safety nets. Your personal edge won't be who types fastest, but who can orchestrate tests, tooling, and models so that fragile ideas harden into reliable systems without slowing to a crawl. Your challenge this week: pick one small feature and let an assistant draft only the dull parts while you handcraft the hardest branch. Then swap. Have it refactor your code and you review it like a rival's PR. Notice where you feel uneasy. Those pressure points are where to invest clearer patterns, tests, and team conventions next. This was OwlUp, your daily step forward. This series continues with more chapters on OwlUp.co. Visit OwlUp.co to access the complete course and continue your learning journey. See you there!